from philosophy into science, there's no leisure trance.
Hey guys, how's it going, everyone? I am here to do some chemistry problems. Let's do this. So, first off, how's everyone doing tonight? Hopefully, everyone's doing well. Getting all their homework in, and doing all of the schoolwork you have until then. If you can't hear me or anything, make sure to just let me know if my mic is too quiet or loud or anything. So, this is the first stream that I'm going to be doing. Just so everyone knows, this is going to be just a time for me to not be interrupted. Hey, buddy, can you head out and close the door, please? I love you too. Buddy. Okay, no. It's not time now. Odin, out. Love you. Yeah, this is what happens whenever you have children, people. Look into that. All right. So, what I'm going to be doing is essentially just going through a bunch of practice problems. If you have specific questions, specific things that you want to know, show up and say something, and I will go do them. So, what have we actually learned in the past week? Mainly, it's been math week. It's let's learn how to do dimensional analysis, convert units, factor label method, all of these different ways of saying the same thing. Essentially, taking a word problem here and turning it into an actual equation. So, that's going to be kind of what I'm going to start off with. After that, I know some people had some problems with sig figs, so I figured I'd go through and run through some significant figures. And then after that, for all the AP people out there, we went through going from grams to moles to atoms. Essentially, dimensional analysis, practical dimensional analysis in chemistry. So all you pre-AP people out there can still get something out of this. It's still dimensional analysis. It's just doing it for chemistry. I haven't gotten there quite yet with you guys, but we will. All right. Let's go through. Let's start. Okay. So, this is a worksheet I found. It has a whole bunch of different things. There's some of these are pretty straightforward, like how many inches in a football field, how to, story to meters, meters to centimeters, centimeters to inches, inches to feet, so on and so forth. Those are pretty straightforward, so I figured we'd do something a little bit more complicated. Part of the reason I like dimensional analysis is because it can take these problems that don't have clear-cut variables in them. You have to go through and find the variables that you are going to be using. And then also go through and look for any type of conversions that they're giving you as well. So let's go through and do this. All right. So, first question. There are 2,850.5 miles between Houston and Vancouver, site of the 2010 Olympic Games. How many meters is that equal to? If we have 1 mile equal to 1.6 kilometers, express your answer in scientific notation. Okay, so this one's pretty straightforward. This is just kind of a one-step conversion that's not going to be very difficult. What are we looking for? Step one. What are we looking for? Right. How many meters? So we know our end goal is going to be in meters. And then what do we have? Well, we have one variable, one thing that we know, a measurement. And then we have this conversion. We know that 1 mile is 1.6 kilometers. So again, you kind of put like 1 mile over 1.6 kilometers or 1.6 kilometers over 1 mile. Whatever we need when we need it. So we're looking for meters. And look around at what we have. Well, we don't have meters, but we do have kilometers. So let's put this guy on top to match the meters here. So kilometers over a mile, and we know that's 1.6 kilometers is 1 mile. All right, now we have this unit up here, this measurement, this variable. It is in miles, which is good because we need to get rid of these miles on bottom. So to cancel these out, one needs to be on top, one needs to be on bottom. So this mile is going to go on top. This mile is going to go on top here. 2,850.5. And that means that the miles cancel. So now all we are left with is kilometers. But we don't want kilometers, we want meters. So I know from scientific notation, I know from just metric system that 1 kilometer equals 1,000 meters. There we go. So I'm going to put the kilometers on bottom so they can cancel. Using this conversion, that means meters is on top. You can fill in those numbers. Okay, kilometers, go there. So you may have noticed something, that if I'm using a measurement, I'm not always going to have a top and a bottom. Sometimes I will, like if it's density or speed or something like that, where it's miles per hour or grams per milliliter, then you do have a top and a bottom, and it can flip just like always. Sometimes you don't. Like up here, this doesn't have a bottom. It's just miles. If I measure the distance in something, it's going to be just in centimeters, just by itself, which means it's not going to have a bottom. You can still flip it if need be, because remember, everything kind of has that 1. But, so there's that. Okay, double check ourselves. Kilometers, cancel. Miles, cancel. We're left with meters. And now we can just plug and chug. So that's how we could go about setting that up. Yep. Okay. So, if you guys have any questions, feel free to just throw them into the chat room. I have it here. There is no such thing as a stupid question. Lay it out. Most people that do join don't even use their real names. So, you know, that's fine. All right. All right, next one here. A newborn baby eats 8 times a day. This is very true. usually a lot more. Each feeding, he eats 2.5 ounces of formula. So one feeding is 2.5 ounces of formula. How many days would it take for the baby to eat 1,000 ounces? So I've underlined all of the things that we're going to be needing. Here we have 8 feedings in one day. So this is going to be a conversion that we're going to be using. One feeding is 2.5 ounces. It's going to be one of the conversions. And then we have this measurement here, 1,000 ounces. And what are we after? How many days? Okay, so this is our first step. We are trying to get to days. All right. So look through all of the other stuff, and here we have day. We want day on top because that's what we're gonna be getting to in the end. So day per feeding. I was gonna say FE for feeding. And it is 8 feedings in one day. Okay, so now I gotta get rid of this feeding. Okay, here's a feeding. So it is one feeding for every 2.5 ounces of formula. That sounds good. Let's use that. I need to get rid of the feeding to cancel it out. One's on bottom, one's on top. Okay, and then that's ounces. I'm just gonna say ounces. There. And that is one feeding for every 2.5 ounces. Okay. Last thing we need to get, the feedings will cancel. Last thing we need to get rid of is the ounces. So we'll put ounces on top. And what do you know? We have ounces right there. So 1,000 ounces. Okay. And now to actually get this, 1 divided by 8 divided by 2.5 times 1,000. That is going to be how many days it takes. How many days is that? Calc. Let's check this out. So, 1 divided by 8 divided by 2.5 times 1,000. 50 days. About 2 months. Yeah, no, that sounds about right. Okay. So, that's how we can go about solving things like this. Unit conversion factor labeling method is really great at whenever you have a lot of these type of, a baby eats 8 times a day. Each feeding he eats 2.5 ounces. Anytime there's it seems like there's a lot of steps, dimensional analysis can be really helpful for that because you can actually lay out all your steps. Make sure that your steps are in the right place. Cancel everything. So the feedings cancel, the ounces cancel, and you can double check. I have a day. Days are what I'm after. I'm good. All right. Next one. Jonathan raised 60 goats. How high did he raise them? No, I'm joking. But Jonathan raised 60 goats, then entered into a series of business transactions. Shady. He traded all of the goats for sheep at an exchange rate of 5 goats for 7 sheep. Next, he exchanged all the sheep for hogs at a rate of 2 sheep for 2 hogs. How many hogs did he get? All right. Well, I mean, okay. This is a pretty straightforward one because we have 5 goats equals 7 sheep. 4 sheep is 2 hogs. You start with 60. At the end, you want to make sure that you have hogs at the end. So, hogs are going to be what we're after. I'm going to say H for hogs, S for sheep, and G for goats. So, we need hogs are going to be the thing we're looking for. We need to find something with hogs. Well, right here. Okay. So 2H over 4S. 2 hogs is 4 sheep. Okay. Next up, here we go. We need to cancel sheep, so the sheep are going to go up top. and put goats on bottom. I'm using this guy, putting sheep on top, goats on bottom. That's 7 sheep, 5 goats. Alright, so we know the sheep's cancel. And then we need to get goats. We have goats to start with. This is the measurement, so it's not going to have a bottom. So goats are going to go here. 60. Cancel out the goats. Double check our units. Yes, we have hogs. We're trying to get the hogs. This is set up correctly. So now we can go through and actually do calculations. To calculate it, start out with 2 divided by 4 times 7 divided by 5 times 60. 42. He has 42 hogs. That's really good. It's not a decimal answer because I don't know if that hog would make it back to the farm. Maybe if it was like 0.99. All right. Bob. All right. I'm gonna do 1, 2, 3. I'm gonna do 4 more, and then move on to sig figs. I think that'll be good. I do want to get to kind of getting into grams, moles, and atoms. So let's do this. All right. There we go. All right. Eggs are shipped from a poultry farm in trucks. Each carton of eggs holds 12 eggs. The carton of eggs is then placed into a crate that holds 20 cartons. Each carton is packed into trucks that can hold 3,125 crates of eggs. How many truckloads will it take to carry 3.75 times 10 to the 6th eggs? All right. Again, this is pretty straightforward. What are we looking for? We need truckloads. Okay, so truck. I'm just gonna make this a T. This is gonna be what we're after. Okay, let's go through and look at everything we know. We know that a carton holds 12 eggs, and then a crate holds 1 crate is 20 cartons, and then a truck is 3,125 crates. Okay, and then the last thing we have is the number of eggs. All right. So again, in the end, we want trucks. I have a. Hey there. What's up? No, it should be under the sink. Okay. All right. I'm glad I'm streaming. Not dealing with it with whatever my wife has to deal with right now. Okay. So we're trying to get to trucks. Okay. Which one of these guys is trucks? Here we go. So we know that 1 truck, 1 T is 3,125 crates. Okay. And now we need to get rid of the crates. We know that 1 crate is 20 cartons, so 1 crate. 20 cartons. Just say cart. The crates cancel. Okay. And we know each carton holds 20 eggs. So 1 carton is 12 eggs. And the last thing, carts cancel. Last thing we need is to get rid of the eggs. We have this measurement here to help us out. 3.75 times 10 to the 6th eggs. Eggs cancel. Double check to make sure everything cancels. Crates cancel, cart cancels, eggs cancel, left with trucks. Trying to get the trucks. We set it up correctly. We're done. All right. Let's see. Let's actually calculate this. I'm interested. Okay. So 1 divided by 3,125 divided by 20 divided by 12. And then we're going to multiply this by 6.75. Trying to remember which one was the E button. There we go. That one. E to the 6th. Remember, E is a fancy way of saying times 10 to the. So there's that. 5. 5 trucks is the answer. I love it whenever you have these giant numbers and then it rolls down to something nice, quick, and simple. Easy. Okay. Alright, let's do one more. Okay. A chemistry teacher spends 5 minutes grading one student's lab. No. No. It takes me a lot longer. I do big lab reports though. So, a chemistry teacher spends 5 minutes grading one student's lab. She has 150 students who turned in lab papers for each lab. If you do 25 labs in a class, how many minutes does this teacher spend grading lab papers? So we need minutes, okay? And what are the things we have? 5 minutes for one student's lab, 150 students, and 25 labs in a class. So this is interesting because it's 5 minutes per student lab. So you can kind of think of student and lab as 2 separate units that are both on bottom. I'm going to get rid of students and I'm going to get rid of labs. So let's go through and do it. What are we actually looking for? How many? That's kind of my keyword that I look for. How many minutes? All right, I need minutes over here. Minutes on top. Which one of these has minutes in it? Right here. So it's 5 minutes over one, let's say, stew lab. And I need to cancel out both the students and the labs here. So it's 150 students. That cancels, but I still have my lab. And then I had to do 25 labs. Labs cancel. And so 5 times 150 times 25. It's a lot. That's, more than, more than the Star Wars trilogy, that's for sure. Let's check though. 5 times 150 times 25. This many minutes. What is that? So divide by 60. 312 hours. That is quite a bit. I don't think that's larger than the Marvel Cinematic Universe. Maybe it is. Okay. All right, so there's that. So I think you guys get it. If anyone has any questions about it, let me know. I think I'm gonna be stopping here with dimensional analysis for now. But let's get into sig figs. So what I'm gonna do 5 of each. I'm gonna do 5 where we just count the number of sig figs, 5 where we multiply, and then 5 where we add and subtract. All right. Let's do it. How many sig figs of these? This first one is going to be 0.006. How many sig figs is this? Remember that the leading zeros never count. There's only one non-zero, so that's going to be 1. Shoot. Load more problems like this. Hey, I got that one right, though. All right. So I can't hit enter. Good to know. So this first one is in scientific notation. Anytime you see scientific notation, just count the digits in the base, even if they're zeros, because it is going to be the correct number of sig figs. So for this one, it's going to be 1. This one, it's going to be 3. This one, it's going to be 3. This one's going to be 4. This one is not scientific notation. So we have to go through and think. There's no leading zeros. There are these 2 back zeros, but we don't see any decimal place. So that means these back zeros are not significant. We're only talking about these guys. And that is 1, 2, 3, 4, 5, 6. Grade it. Hooray. All right. So now let's go through and do the same thing, but multiplying and dividing. All right. So with rules for multiplication and division is the following. Figure out how many sig figs each number is here. These 2 are in scientific notation. And then your answer is going to be rounded to the lower number of sig figs here. So this first one, 1, 2, 3. This one is going to be 1. So we're going to round to 1 sig fig here, whatever this turns out to be. Let's do this real quick. 8.15 e to the 4th. Whoop. Clear. 8.15 e. Wrong e. 8.15 exponent to the 4th. And then that is going to be multiplied by 2 exponent to the 4th. Big old number. But remember, we're only going to be looking at 1 significant figure here, which means that we're only going to be dealing with this sig fig. Checked in the back. Is this going to round up or down? It's going to round up. So this is going to be, 2,000 something. What is it? No, 2 million? 100,000, million, billion. It's a billion. 2 billion. Or we could say 2 times 10 to the 9. 3, 4, 6, 7, 9. Yeah. So we can write here 2 e 9. E to the 9. All right, next one. Sig fig rules are still the same as before. Leading zeros don't count, so this is 2. These back zeros, there's no decimal, so they don't count. So this one's 3. This is going to be whatever the calculation is here, just round it to 2 sig figs. So we can just calculate this real quick. Okay, 0.025 divided by 963. 1, 2, 3, 4. 2.596 times 10 to the negative 9th. This is going to be 2 sig figs, so these first 2 are the only ones that we're going to be keeping. We are going to be rounding up because the next number down is a 9. So 2.6 times 10 to the times 10 to the negative 9th. Okay. So 2.6 e negative 9. Okay. This next one, same thing. Check the sig figs. These back zeros don't count. There's no decimal. It's going to be 2. This one, back zeros don't count. Just this one, so it's 1. We're going to be using 1 as our sig fig for this answer. We can pull this out and 35000 divided by 6,000. 5.83333 repeating. We said 1, so this is going to turn into 6. Whoop. 6. Okay. Same idea here. These are both scientific notations, so it's easy enough. 3, 4, we're going to be using 3 sig figs for our answer. So let's pull out our calculator and do that. 2.99 e to the third. This is divided by 9.369 e to the 8th. And the answer is going to be 3.19 times 10 to the negative 6th. We are looking for 3 sig figs here. So it's going to be these first 3. Back number's 1. We don't count it. Or it's going to round down. So 3.19 e to the negative 6. E to the negative 6. All right, guys, last one. So here, 3 sig figs. Here, 3 sig figs. God, I love scientific notation. Just makes things so much easier. So it's going to be 3 sig figs. Okay? 3 sig figs. We can pull out the calculator. And that's going to be 2.18 e to the 6th divided by 2.59 e to the 3rd. 3 sig figs is going to be these first 3. The 6 is going to make it round up, so 842. 842. Grade it. Look at that, get them all wrong. Hey, I did it. Hooray. So, there's that. Let's start over with the main menu. This one is going to be more difficult because it is addition and subtraction. So I'm not going to be doing scientific notation. Well, sure, I'll do scientific notation as well. Pardon me. All right, let's do it. Okay. So, the rules for addition and subtraction when it comes to scientific notation is you look at the 2 numbers you have, and then you are going to figure out the places where the scientific notations stop, or the significant figures stop. So, what we can do is go 1, 2, 3, 4, 5, 6, 7. This is the 8th place up from the decimal. This one is the 10th place, so it's 1 place to the right of the decimal. And what is this? 10 millions? Yeah, the 10 millions place. And whichever one is larger, so this 10 millions place is larger, this is going to be what we round to. And this is exactly why, this is a good example on why we do this. So I have this huge number, 70 million, and I'm just subtracting 0.385, just a tiny little sliver off of it. Now, based on the sig figs of this, I can't tell, if this number here, if this was 10 million pounds, the scale I'm using doesn't let me know if it's 10 million and 1 pounds or 10 million and, 70 million and 1 pounds or 69,999,999 pounds. It could be in between there. In fact, based on these sig figs, I don't know if it's 71 million pounds or 69 million pounds. I'm not sure about that. So removing this little bit, I'm not for sure if I'm I cannot change this measurement because this is well within that level of uncertainty that I don't know. So that's why we do this. How to do it is, like I said before, figure out where the sig figs end, which place, the larger place, round to that place. So in this case, I'm going to round to the 10 millions place. I'm not even going to do the math in my head. It's going to be slightly less than 700 or 70 million and then I'm going to round back up to 70 million. 1, 2, 3, 1, 2, 3. Okay. Here, it's a little different. I'm going to pull out my marker again. So I'm going to change this to standard notation real quick to show you what I mean. 1, 2, 3. So this is going to be 1.4, or no, not 1.4. What is it? 1,450. If I change this to normal notation, and this is going to be, what is that? 700,000. So if I move this over 6, no, that's million. That's 7 million. Yep. Yeah. So that's 7 million. So the same thing is going to be true here. I have this this big mass, 7 million pounds, and I'm going to add in another 1,000 pounds. I don't know if this is 7 million, 71 or 7.1 million or 6.9 million pounds. So I'm just gonna, I don't know how much I'm actually adding here. To go through the process though, this 5 is in the tens place. This 7 here is going to be in the millions place. I'm going to go with the millions place. I'm going to round this to a million. If I actually wanted to go through and check it, 7 million minus 1,450, it's going to be this number. I'm going to round to the millions place, which means I'm going to round back up to 7 million. Okay, this one's going to be similar, but this one's not so obvious whenever you're thinking about, you know, like 1 million pounds and you take a handful away of the material. This one's a little bit more subtle, but we can do the exact same idea. The significant figures here is in the tens place. Here it's in the thousands place. So I'm going to round to the thousands place, whatever this turns out to be. And we're going to pull out our calculator. And we can do that calculation. 89660 minus 28000. We have a thing. We're going to round to the thousands place. So that means we're going to round right here. We're going to round up. So the next number is a 6. So it's going to be 62,000. Oh, that's not. Did I say 62,000 or? Yeah, 62,000. Okay. Yes, 62,000. Same idea here. We're gonna. This ends on the ones place. This ends on the tenths place. So that means we're gonna round to the ones place here. 197 minus 9.5. I'm just gonna do this with my calculator. It's late. I'm tired. I need to make use of the machine in front of me. 187.5. We'll round up because that's how we're going to be doing this, and which makes it 188. 188. This one's nice and simple. Again, you don't even really need to do anything. This is so small, it's to the thousands place. Here, the sig fig ends at the hundreds place. We're going to use the hundreds place to round to. So 6,900 minus some tiny little amount is going to round to 6,900. Hooray! If sig figs are still troubling you, run through this. You know, do 5 a night. It's a practice. Because if you don't, they're just going to keep coming back up and biting you in the butt and just, you know, be painful. Run through it. Like I said, the chemistry's, I consider chemistry to be a lot like sports. You know, you need to do 10,000 free throws. Sig figs are like that. You know, you should never miss a point because of sig figs. Because because you should be using sig figs all the time. You should never miss a free throw. Okay. All right. That is that. I am going to run to the bathroom. I'm going to be right back. I'm going. I'm going to take a little 3, 4, 5 minute break or so. I might grab another soda while I'm at it. All right. Stick around. Listen to lo-fi hip hop beats to study to while I'm gone. All right. Have a good one. And we're back. Okay. So now we're going to go through and do some mole calculations. Okay. How do we go from grams of a certain substance to moles of a certain substance and back again? That's going to be our next goal. So, for you pre-AP people, same idea with dimensional analysis, except instead of using like 1 foot is 12 inches, we are going to use something called the molecular mass, and you get that through the periodic table. Okay, so I got my periodic table here to help us out. All right, same thing as before. How many moles are in 40.0 grams of water? Okay. For those of you that don't know, water is H2O. That is going to be very helpful for us. What are we looking for? How many moles? Moles are it's right here. That's going to be what we're looking for. We know that there are 40 grams of water, so that's going to be one thing that we're going to be using. The other thing we're going to be using is grams per mole. This is going to be the atomic weight, molecular mass of H2O. So I know that hydrogen is 1.008. I'm just going to say 1 for this. And there's 2 of them, so that means I have 2 so far, 2 grams per mole for H2. And O is 15.999. I'm going to say 16 to make it easy. So that's going to be 2 for the hydrogens, and that one oxygen is 16, so it's a total of 18. So it's going to be 18 grams for 1 mole. All right. Now do you kind of see what's going to be happening here? I have moles that I'm going to be wanting to get to. Which one of these things has moles? This guy. I'm gonna have to flip it. So 1 mole over 18 grams. And to get rid of the grams, I'm going to use this 40.0 grams. And there we go. It's all set up. Grams canceled. We have moles. Moles are there. We're good. So I know that I'm going to take 1 divided by 18 times 40. Or I can just think 40 divided by 18. All right. So let's go through and do that. 40 divided by 18. 2.22222. Geez, that's a big old number. How are we ever going to get that number? Sig figs. So sig figs are going to be what we are after. It is 40.0. This is the only real measurement we have. This is a conversion. We got this off of a chart, so we're not going to count the sig figs for this. It's going to be infinite sig figs. So we're going to stick with 3 sig figs here. So 2.22 is going to be what we're going to be using. That means we're going to round down. So 2.22 moles. 2.22 moles. And there we go. If I were going to be doing this for realsies, I definitely would not round these numbers. In fact, let's go through and not round these numbers real quick. So it's going to be, for the 2 hydrogens, 2.016 is going to be for the 2 hydrogens. I'll put this right here. 2.016 plus 15.9999. 18.0159. This is going to be what we're going to be using for that molecular weight. So instead of 18, we're going to be using 18.0159. 0.0159. You can really small there. So now I can say 40.0 divided by 18.0159, and these 3 sig figs, and we're still rounding down, so we're good. We don't have to worry about that. Okay. Bop, bop, bop. Same thing. How many grams are in 3.7 moles of sodium oxide? So this is sodium oxide. If you don't know the names for these things, don't worry, we'll get there. Sodium oxide is going to be Na2O. So let's head over to the periodic table. We're going to be looking for... Get a calculator out again. Sodium, it's right here. So it's going to be 22.990, and we're going to do this by 2 because there's 2 sodiums in sodium oxide. And then we're also going to be adding in oxygen, 15.9999, and that is going to be 61.9799. Okay, so 61. Let me close here. So we know that for sodium hydroxide, we have 61.9799 grams in 1 mole. Okay. That is going to be the molecular weight of sodium oxide there. And the other thing we know is the number of moles. Okay. And we are looking for how many grams. So we're trying to get to grams. Well, which one of these things has grams? The molecular weight here. So it's going to be 61.9799 grams over 1 mole. I need to cancel out the mole. And how I'm going to do that, I'm going to use this measurement here. 37, or 3.7. And we got it set up. We can double check. Our units are canceled. Grams are the only thing that's left. Grams are there. We're all good. And now we can multiply by 3.7, and this is going to be this number. But we don't want to use all these digits. We have to use sig figs, right? So this is a conversion, infinite sig figs. Here's 2 sig figs, so we're only going to be using these 2 sig figs and rounding. We're going to round up, so it's going to be 230 grams. So 230 grams. There we go. So that's that. Okay. I think that's going to be all for tonight. It's 5 minutes to 7. We're kind of, we don't really have a whole lot of concepts or anything going on right now. But this is going to go up on YouTube as soon as I am able to pull it off of Twitch. I will upload it to YouTube. So you'll be able to watch it there. I will see you guys tomorrow on Monday. Be there with bells on. Actually, don't wear nice clothes. We're going to a chemistry lab. That's not smart. Don't do that. Anyway, if you're ever wondering where I'm pulling these things from, I'm just Googling like dimensional analysis homework. And I think this one actually, okay, this one doesn't. But most of the times you can find the keys for these things, so you can work the problem and have the correct answer in front of you. I highly suggest that. If there's something that you're just not getting and you squeaked out, you know, a 9 out of 10 on the problem set, but you want more problem sets, just Google them to practice. That is an amazing way of getting good at this. Remember, it's just practice. Doing practice problems can really help you out. I don't want to just inundate you with them over and over again. If you got it, but if you don't get it, then find out more or just ask. I'll send you some extra problem sets. This is a great way of figuring out sig figs. You know, I just typed in grams, moles, atoms worksheet and this popped up. There's some great ways of getting some good practice in. All right, I will see you guys Monday. Have a good one.